Most people think a navy is defined by its biggest ships. In public imagination, naval power means the aircraft carrier, the missile destroyer, or the submarine that disappears beneath the surface. But a modern fleet is not really a collection of iconic hulls. It is a layered operating system built to control sea space, move force across oceans, protect trade routes, gather intelligence, and, if necessary, deliver violence at long range with precision and endurance. That distinction matters because naval power is often misunderstood as a contest of ship versus ship. In reality, modern warships are designed to operate as part of an interdependent architecture. The carrier provides mobile air power. Escorts defend the formation from aircraft, missiles, and submarines. Attack submarines extend reach and stealth. Amphibious ships move ground forces. Replenishment ships keep everything operating far from home ports. Patrol vessels, mine countermeasure units, and special mission platforms handle the quieter tasks that make maritime order possible in the first place. This is why even the most expensive warship in the world is strategically incomplete on its own. A carrier without escorts is exposed. A destroyer without logistics has limited endurance. A submarine without intelligence support becomes less effective. What appears to be a fleet of separate vessels is actually a tightly linked network of sensors, weapons, aviation, maintenance, communications, and supply. Over the past century, navies evolved from gun-centered battle lines into multi-domain systems that combine sea control, air power, missile defense, and logistical persistence. The names of the ships still matter, but the labels can be misleading. A destroyer in one navy may be cruiser-sized in another. A patrol ship may look modest, yet be central to sovereignty and maritime security. So, to understand how naval power really works, the first question is not which ship is strongest. It is how each class fits into the larger machine. And that machine begins with the vessel that reshaped naval warfare more than any other, the aircraft carrier. To understand modern naval power, it helps to start with the ship that changed the hierarchy of fleets, the aircraft carrier. For much of naval history, the capital ship was the battleship, built around armor and heavy guns. That changed when naval aviation proved that striking power no longer depended on line-of-sight gunfire. The decisive weapon was now the aircraft, and the carrier became the platform that could launch it anywhere in the world without relying on a nearby airbase. Structurally, a carrier is less a ship in the traditional sense than a mobile airfield wrapped in steel, electronics, fuel systems, munitions storage, command facilities, and maintenance infrastructure. Its flight deck is the visible symbol, but the real mechanism lies below it. Hangars, elevators, jet fuel lines, weapons magazines, repair workshops, radar systems, and air traffic control spaces allow the vessel to generate repeated sorties over long periods. In effect, the carrier converts ocean space into temporary sovereign air power. Its function is broader than attack alone. Carrier air wings can conduct air defense, anti-ship strikes, surveillance, electronic warfare, close air support, and reconnaissance. That makes the vessel not just a weapons platform, but a floating command node capable of influencing events hundreds of miles away from the hull itself. During the late 20th century and into the 21st, carriers became central to crisis response because they could arrive without needing basing permission from another state and begin operations almost immediately. But the carrier's importance also reveals its vulnerability. It is large, expensive, and impossible to hide. Its combat value depends on launching aircraft, which means it must be protected long before an enemy gets close enough to see it. That is why a carrier never really fights alone. It requires an outer shield of escorts, submarines, logistics ships, and airborne warning systems to survive in contested waters. In other words, the carrier may be the centerpiece, but it is not the whole structure. To keep this floating airbase alive, navies need ships built for a very different purpose: layered defense and control of the battlespace around it. If the aircraft carrier is the fleet's striking arm, then cruisers, destroyers, and frigates are the shield that keeps it alive. These ships are often grouped together in public discussion, but their real value lies in how they divide defensive labor across a wide area of ocean. A modern fleet survives not because one escort is invulnerable, but because multiple warships create overlapping layers of detection, interception, and response. At the structural level, these surface combatants are built around sensors, missile systems, and command networks. Their radars scan vast volumes of air and sea. Their combat information centers process incoming data, identify threats, and assign weapons in seconds. Vertical launch systems allow a single hull to carry different missile types for anti-air warfare, missile defense, anti-submarine work, and long-range strike. In practical terms, that means one ship can engage aircraft, track ballistic threats, attack targets ashore, and coordinate with other vessels at the same time. The differences between classes are often historical as much as technical. In some navies, cruisers traditionally carried heavier command and control functions and larger missile loads. Destroyers evolved into high-end, multi-mission escorts. Frigates generally became slightly smaller and more specialized, often optimized for convoy protection or anti-submarine warfare. But the boundaries are not universal. One country's destroyer may displace more than another country's cruiser. The label matters less than the role inside the fleet's defensive geometry. A clear example came during the missile age, when naval planners had to adapt from gunnery duels to saturation attacks from aircraft and sea-skimming missiles. Surface combatants became not just escorts, but missile defense nodes. Their job was to detect threats early, share tracks across the task force, and destroy incoming weapons before they could reach the high-value units at the center. That defensive mission, however, has limits. Radar cannot see through water, and some of the most dangerous threats approach from below the surface. To defend a fleet fully, navies need a platform designed not for visibility, but for stealth, persistence, and underwater dominance. To understand why fleets invest so heavily in submarines, it is necessary to reverse the usual logic of naval power. Most warships project influence by being seen. The submarine does the opposite. Its strategic value comes from uncertainty. It forces an opponent to assume that a threat may already be present, even when nothing is visible on radar or the horizon. Structurally, submarines divide into very different categories. Attack submarines are built to hunt ships and other submarines, gather intelligence, and support wider fleet operations. Ballistic missile submarines serve a different purpose entirely, acting as the hidden sea-based leg of a nuclear deterrent. Cruise missile submarines, where operated, sit somewhere in between, combining stealth with long-range strike capacity against land or maritime targets. Diesel-electric boats can be highly effective in regional waters, while nuclear-powered submarines offer the endurance and speed required for global operations. Mechanically, the attack submarine is one of the most disruptive tools in naval warfare because it targets the assumptions that surface fleets depend on. It can trail a carrier group, threaten logistics ships, monitor choke points, insert special operations teams, or collect acoustic intelligence without announcing its presence. Even when it never fires a weapon, it imposes caution, slows movement, and forces surface commanders to devote ships, aircraft, and helicopters to anti-submarine screening. This dynamic reshaped fleet design during the Cold War, when undersea competition became one of the most important and secretive dimensions of naval strategy. Surface groups could not simply maneuver freely. They had to think in terms of sonar coverage, patrol patterns, acoustic signatures, and maritime patrol aircraft support. The ocean became not just a transit zone, but a contested three-dimensional battle space. That is why submarines are often described as independent predators, but in practice, they are deeply tied to the rest of the force. Their success depends on intelligence cues, secure communications, and coordination with air and surface assets. And while they are optimized for stealth and strike, navies also need ships built for an entirely different mission, moving troops, equipment, and combat power from sea to shore. A navy does not exist only to fight at sea. One of its most consequential roles is moving military power from the water onto land, and that is where amphibious warships become essential. These vessels are often overshadowed by carriers and destroyers, yet they perform a different strategic function entirely. They turn maritime access into physical presence, allowing a state to deliver troops, aircraft, vehicles, and command elements to a coastline without depending on fixed infrastructure. At the structural level, amphibious ships are built around lift capacity rather than pure missile firepower. Some are designed with full-length flight decks to operate helicopters and short takeoff aircraft. Others include well decks that can launch landing craft or amphibious vehicles directly into the sea. Inside, they carry Marines or naval infantry, their equipment, medical spaces, maintenance support, fuel, and command facilities. In effect, they are floating transport hubs built for contested entry and expeditionary operations. Mechanically, their usefulness comes from flexibility. An amphibious ready group can support an assault, reinforce an embassy evacuation, deliver disaster relief, or position forces offshore as a form of deterrent signaling. Helicopters extend the landing zone beyond the beach itself. Landing craft move armor, logistics, and personnel ashore, even where ports are damaged or unavailable. That combination gives planners options between full invasion and complete inaction. Historical experience helped redefine this category. Large-scale amphibious assaults once focused on massed beach landings, but modern operations place greater emphasis on dispersed insertion, aviation support, and rapid response. The platform remained relevant by evolving from a specialized invasion ship into a multi-role expeditionary asset. Still, these ships reveal another truth about fleets. Combat power is useless if it cannot be sustained. Amphibious groups burn fuel, consume aviation parts, require ammunition, and depend on steady maintenance support. The same is true for carriers, escorts, and submarines. So beneath every visible display of naval power sits a quieter class of vessel that makes long-range operations possible in the first place, the logistics fleet. The easiest way to misunderstand naval power is to focus only on combat ships. Fleets do not operate on symbolism. They operate on fuel, ammunition, spare parts, food, repair capacity, and timing. That is why logistics ships are among the most strategically important vessels in any navy, even though they are rarely the center of public attention. Without them, high-end warships become short-range assets tied to friendly ports and predictable schedules. Structurally, naval logistics vessels are designed around sustainment rather than combat. Fleet oilers carry the fuel that keeps carriers, destroyers, frigates, and aviation detachments moving. Ammunition ships transport missiles, bombs, and other ordnance needed to maintain combat tempo. Fast combat support ships combine multiple supply functions to keep task groups operating with fewer interruptions. Other auxiliaries carry spare parts, dry goods, refrigerated stores, repair equipment, or medical support. Their design reflects a simple reality. Endurance at sea is not just about distance, but about replenishment cycles. Mechanically, the key innovation is underway replenishment. Instead of returning to port, combat ships can receive fuel and supplies while still at sea, often while both vessels remain in motion. That process is technically demanding and operationally sensitive, but it allows fleets to preserve momentum across enormous distances. A carrier strike group operating thousands of miles from home waters is only as persistent as its supply chain. The visible warships may project power, but the auxiliaries determine how long that projection can continue. This became especially clear in the era of global operations, when navies shifted from coastal defense to sustained forward presence. A fleet that can replenish at sea gains strategic elasticity. It can remain on station longer, respond faster to crises, and avoid becoming dependent on access to foreign bases. In practice, logistics determines whether naval strategy is regional, oceanic, or truly global. And logistics is not only about keeping ships fueled, it is also about keeping sea lanes usable. Because before fleets can maneuver safely through contested waters, they often face a quieter and highly disruptive threat buried in the maritime environment itself: naval mines and the vessels built to defeat them. Some of the most effective naval weapons are also the least visible. Mines do not require a fleet action, a missile duel, or even direct contact with the enemy. They exploit geography, traffic patterns, and uncertainty. A relatively low-cost minefield can delay an amphibious assault, block commercial shipping, restrict fleet movement, or force a stronger navy into slow and resource-intensive clearance work. That is why mine warfare remains one of the most understated but consequential layers of maritime strategy. Structurally, mine warfare includes both offensive and defensive systems. On the offensive side, mines can be laid by ships, submarines, or aircraft to deny access to ports, choke points, and coastal approaches. On the defensive side, navies operate specialized mine countermeasure vessels, helicopters, divers, remotely operated vehicles, and sonar systems designed to detect, classify, and neutralize underwater threats. These platforms are usually smaller and less heavily armed than frontline combatants, but their mission is highly technical and strategically vital. Mechanically, mine countermeasures are slow because they must be precise. Crews cannot simply sweep every contact with brute force. They have to map the seabed, distinguish actual mines from debris, and then neutralize threats without triggering wider damage. In shallow coastal waters, harbors, and narrow straits, that process becomes even more difficult. A single suspected mine can alter shipping routes, delay military operations, and force commanders to commit disproportionate resources just to restore confidence in safe passage. This pattern has appeared repeatedly in modern maritime operations. Mines have damaged warships, disrupted trade, and imposed caution on far stronger fleets than the states or actors deploying them. Their value lies less in destruction alone than in the operational friction they create. They turn movement into risk calculation. That makes mine warfare a reminder that naval power is not only about striking first, it is also about securing access, protecting commerce, and maintaining control over crowded maritime space. And outside major fleet operations, that broader day-to-day control often falls to a different class of vessel built not for global war, but for constant presence in coastal and regional waters. Not every naval mission requires a carrier group or a heavily armed destroyer. Much of maritime control is exercised through ships that are smaller, cheaper, and less visible in public debate. Patrol vessels, corvettes, offshore patrol ships, and fast attack craft occupy this layer of naval structure. They are designed not for sustained global warfare, but for persistent presence in territorial waters, exclusive economic zones, choke points, and near-shore environments where daily state authority is actually tested. Structurally, these vessels vary widely because their missions vary widely. Some are lightly armed and optimized for surveillance, boarding operations, fisheries enforcement, and sovereignty patrols. Others, especially corvettes and missile craft, carry anti-ship missiles, guns, and air defense systems that make them credible combatants in confined regional seas. Offshore patrol vessels emphasize endurance and maritime security, while fast attack craft trade endurance for speed and concentrated firepower. The category is broad, but the logic is consistent. Not every problem at sea requires an ocean-going capital ship. Mechanically, these platforms fill the gap between naval warfare and maritime policing. They intercept suspicious traffic, monitor shipping lanes, shadow foreign vessels, enforce sanctions, respond to piracy, and maintain a flag presence in disputed waters. In a crisis, they can become the first line of contact long before larger fleet units arrive. In peacetime, they are often the ships that actually define how a state's maritime claims are felt on the water. This became increasingly important as navies adapted to gray zone competition, where pressure is applied below the threshold of open conflict. In such environments, a patrol ship may have more practical strategic relevance than a major surface combatant simply because it is present more often and can operate with less escalation risk. These ships normalize authority through repetition. But persistence in coastal waters is only one piece of maritime control. Modern navies also rely on specialized vessels that do not fit neatly into traditional combat categories at all. Because to monitor, map, support, and exploit the maritime domain, fleets need ships built for missions far beyond direct combat. To see how a navy really functions, it is necessary to look beyond its obvious combatants and focus on the specialized ships that make the rest of the force usable. These vessels rarely dominate headlines, yet they perform the technical work that allows fleets to navigate, communicate, survey, rescue, transport, and sustain operations across wide maritime theaters. They are the support architecture that turns a collection of ships into a coherent operating system. Structurally, this category includes intelligence ships, oceanographic survey vessels, hydrographic platforms, submarine rescue ships, repair tenders, command ships, training vessels, and hospital ships. Each serves a narrow, institutional purpose, but together they solve problems that frontline combatants are not built to handle efficiently. Survey ships map the seabed and collect data needed for navigation, mine warfare, and submarine operations. Command ships provide additional communications and planning capacity for large formations. Rescue and salvage vessels recover damaged equipment, support divers, and respond to underwater emergencies. Mechanically, these ships extend naval capability in quiet but critical ways. A fleet operating near unfamiliar waters depends on hydrographic information to understand depth, currents, seabed composition, and navigational hazards. Submarines rely on acoustic knowledge of the undersea environment to maneuver effectively and avoid detection. Hospital ships and medical support vessels expand endurance by providing treatment capacity during combat, disaster response, or humanitarian missions. Intelligence collection platforms gather signals and maritime data that help commanders understand traffic patterns and emerging threats before a crisis fully develops. Their importance tends to become visible only when something goes wrong. A damaged submarine, a mine threat in poorly mapped waters, or a large-scale evacuation can quickly reveal how much naval effectiveness depends on these niche capabilities. They represent institutional depth rather than raw firepower. This also shows that naval strength is not measured only by ship numbers or missile counts. It depends on how well a navy integrates combat power with information, rescue, repair, command, and technical support. And in the modern era, one of the most important support layers does not sit on the sea at all. It operates above it, extending the fleet's sensors far beyond the horizon through naval aviation. A fleet that can only see to the horizon is already at a disadvantage. That is why naval aviation is not simply an accessory to ships, but one of the core systems that makes maritime power work at modern range. Long before an enemy vessel, submarine, or missile enters visual distance, aircraft can search vast areas of ocean, relay targeting information, track contacts, and extend the fleet's reaction time. In practical terms, aviation expands the Navy's awareness, reach, and speed of decision. Structurally, naval aviation includes far more than carrier-based fighter jets. It also includes maritime patrol aircraft, shipborne helicopters, airborne early warning platforms, electronic warfare aircraft, transport planes, and unmanned systems. Each performs a specific layer of work. Maritime patrol aircraft scan large areas for submarines and surface contacts. Helicopters provide anti-submarine coverage, utility lift, search and rescue, and over-the-horizon targeting support from destroyers, frigates, and amphibious ships. Airborne early warning platforms extend radar coverage and help coordinate air defense across the fleet. Mechanically, these aircraft solve problems ships cannot solve efficiently on their own. A surface combatant's radar is limited by curvature of the Earth. A helicopter can push detection outward. A maritime patrol aircraft can investigate a submarine contact far faster than any ship can reposition. An airborne early warning aircraft can identify incoming threats sooner, allowing missile defense ships more time to classify and engage. In anti-submarine warfare especially, aviation is often the connective tissue between sonar detections, surface escorts, and submarine hunters. This became increasingly important as fleets faced longer-range missiles, quieter submarines, and wider operating areas. Naval commanders could no longer depend on the ship as the sole center of sensing and response. The fleet had to function as an air-sea network, with aviation closing the gaps between scattered vessels and uncertain contacts, but information and reach alone are not enough. A navy also needs a way to turn all of these ships, aircraft, sensors, and weapons into one coordinated structure. Because the more complex the fleet becomes, the more decisive its command system becomes. The larger a fleet becomes, the less decisive any single ship is on its own. What matters instead is whether commanders can combine dispersed vessels, aircraft, submarines, and support units into one functioning system. This is the role of command and control, the invisible framework that tells the fleet what it knows, how fast it can respond, and whether separate platforms are acting as a coordinated force or merely operating in parallel. Structurally, naval command is layered. Individual ships manage their own sensors, weapons, engineering, and immediate tactical decisions. Task groups combine multiple vessels under a single operational commander. Larger fleet commands integrate regional objectives, logistics, intelligence, and political direction from national leadership. At each level, the quality of communication matters as much as the quality of the ships themselves. Secure data links, satellite communications, combat information centers, and shared operational pictures allow commanders to distribute information across the force rather than trapping it inside one hull. Mechanically, this system works by compressing time. A radar track detected by one ship can be passed to another, better positioned to engage. A maritime patrol aircraft can cue a destroyer toward a submarine contact. A flagship or shore-based command center can redirect escorts, allocate aircraft, and prioritize threats across a theater. In a high-tempo environment, the fleet that processes information faster often gains the advantage before weapons are even launched. This is also why electronic warfare, cyber resilience, and communications discipline have become central to naval planning. Command systems create power, but they also create dependency. If networks are jammed, spoofed, intercepted, or degraded, even sophisticated fleets can lose coherence. Modern naval warfare is therefore not just a test of firepower, but of information management under pressure. Historically, the shift from signal flags and radio voice traffic to networked battle management transformed fleets from formations into distributed combat systems. But coordination is only useful if the force itself can survive enemy pressure. And in modern naval operations, that pressure is increasingly shaped by the missile systems that now define range, risk, and strategic escalation at sea. The modern warship is no longer defined primarily by its gun. It is defined by the missile envelope around it. Missiles determine how far a ship can strike, how early it must defend itself, and how much risk a commander assumes by entering contested waters. This shift has changed naval warfare from an era of visible engagement into one shaped by detection range, targeting quality, and the speed of interception. Structurally, missile warfare at sea divides into several overlapping categories. Anti-ship missiles are designed to cripple or sink surface targets at long distance. Land attack cruise missiles allow ships and submarines to strike command nodes, infrastructure, and military facilities far inland. Surface-to-air missiles defend the fleet against aircraft, drones, and incoming weapons. In some navies, ballistic missile defense adds yet another layer, requiring sensors and interceptors capable of responding to threats on vastly different trajectories and timelines. A single combatant may carry several of these functions at once through vertical launch systems and integrated fire control networks. Mechanically, the challenge is not just firing missiles, but building the kill chain that makes them useful. A ship needs to detect or receive targeting data, identify the contact correctly, decide on engagement, launch at the right moment, and then either guide the weapon or rely on the missile's own seeker. On defense, the process runs in reverse under greater time pressure. Detect the inbound threat, classify it, assign the right interceptor, and if necessary, fall back to close-in guns or electronic countermeasures. The result is a layered contest measured in seconds. This changed naval strategy because range no longer guarantees safety. A fleet can threaten targets far beyond the horizon, but it can also be threatened from similarly extended distances by aircraft, submarines, coastal batteries, or even smaller vessels using modern missiles. Sea control has become more conditional and more expensive to maintain. That is the strategic reality missiles impose. Power can be projected at greater distance, but survivability becomes harder to guarantee, which is why the final question is not what any single ship can do, but what all of these classes together mean in the wider geopolitical system that navies are built to serve. By the time all of these ship classes are placed together, a navy stops looking like a list of vessels and starts looking like a national instrument. Carriers provide mobile air power. Escorts build defensive layers. Submarines impose uncertainty below the surface. Amphibious ships move force ashore. Logistics vessels sustain endurance. Mine warfare units secure access. Patrol ships maintain daily presence. Specialized support platforms provide the technical depth that keeps everything functioning. The real subject is no longer the ship itself, but the system created when all of them are organized towards strategy. That system serves different purposes depending on the state operating it. For a global power, the Navy may protect trade routes, deter rivals, support alliances, and maintain forward presence across multiple oceans. For a regional power, it may focus on coastal defense, choke point control, anti-access strategy, and sovereignty enforcement in nearby waters. For smaller states, even a modest fleet can still matter if it is optimized for patrol, denial, mine warfare, or missile-based deterrence. Naval design always reflects political geography. Mechanically, this is where doctrine becomes decisive. A fleet built for sea control looks different from one built for sea denial. A navy designed around alliance integration emphasizes interoperability, logistics, and communications. One built for homeland defense may prioritize submarines, coastal missile networks, and smaller surface combatants. In every case, ship classes are not isolated purchases. They are policy choices made visible in steel, electronics, training pipelines, and basing infrastructure. This also explains why naval competition is rarely just about counting hulls. Numbers matter, but composition matters more. A fleet with impressive capital ships but weak logistics, limited anti-submarine capacity, or poor maintenance may struggle to sustain operations. Another fleet with fewer ships but better integration and clearer doctrine may generate greater real-world effect. So the final layer of the breakdown is not operational, but strategic. Once naval power is understood as a long-term system of presence, deterrence, logistics, and statecraft, the central question becomes how that system will adapt to a world of contested seas, autonomous systems, tighter budgets, and increasingly networked conflict. In the end, a navy is best understood not as a parade of powerful ships, but as a maritime operating system built to manage distance, uncertainty, and force projection. Public attention gravitates toward the most visible platforms, especially carriers, submarines, and missile destroyers. But the strategic reality is broader. Naval effectiveness comes from the interaction between strike power, defense, logistics, mobility, information, and sustained presence across enormous spaces that no land-based institution can control in the same way. That is what makes warships important beyond war itself. They protect shipping lanes that carry energy, food, raw materials, and manufactured goods. They reassure allies through forward deployment. They support evacuations, humanitarian missions, embargo enforcement, and deterrence patrols. They gather intelligence, maintain access to choke points, and create options for national leadership before crises harden into open conflict. A fleet's peacetime role is often as consequential as its wartime role, because it shapes the environment in which political decisions are made. The challenge for modern navies is that this mission is becoming more complex, not less. Precision missiles extend threat range. Quiet submarines complicate detection. Drones and autonomous systems are beginning to alter reconnaissance, mine warfare, and strike operations. Space-based and cyber-linked networks make fleets more informed, but also more dependent on vulnerable digital architecture. At the same time, maintaining large warships remains extraordinarily expensive, forcing governments to balance prestige, readiness, industrial capacity, and strategic necessity. So the future of naval power will not be decided by one revolutionary ship class alone. It will depend on how successfully navies integrate old functions with new technologies while preserving the fundamentals that have always mattered: endurance, coordination, access, and control of maritime space. The sea remains the connective tissue of the global system, and the fleets that operate across it are not simply weapons at sea. They are instruments for shaping trade, deterrence, crisis response, and geopolitical reach in a world that still depends on the oceans more than most people realize.